Hey everybody. Um, so today we're going to skip around a little bit in the notes packet. Tuesday's lecture in class was over second order integrated rate law, but I want to do the two examples for first order integrated rate law. So first order reaction, this is talking about the overall reaction. First order integrated rate law. And integrated does mean the same thing in calculus, take the integral, and this is what you come up with. I'm not going to show the derivation, although you guys could understand it, but all you need to know, and you will be giving these equations, but the first order rate law, integrated rate law, is the natural log of the concentration at a certain time, t, minus the natural log of the reactant concentration at initially. The zero means initially. And that's going to equal, that difference is going to equal negative the rate constant times the time. And really, a lot of these problems is just about plug and chug. You do need to know that the inverse of a natural log is taking e to the power. And really, that's the biggest thing you need to know. And really, these things are just plug and chug. So this is page 15-12. And what we're going to do is determine the initial. So cyclobutane decomposes at 1000 degrees Celsius to 2 molecules of ethylene with a very high rate constant of 87 inverse seconds. So and that is, says it's the rate constant, therefore that is K. A, example 1, part A. If the initial concentration of cyclobutane is 2 molar, so the concentration initial is 2 molar. What is the concentration? At 0.010 seconds. So in other words, we are looking for the concentration of C4H8 at time t. So you just plug it in and do some algebra. We're going to use the natural log of the C4H8 at 0.010 seconds minus the natural log of the C4H8 concentration initial. And that's going to equal the negative rate constant times the time. The change in time should be, but times the time. So that gives us the natural log of the C4H8 H8 concentration at 0.010 seconds minus the natural log of 2, right? Plug in your numbers, equals negative 87 times the time, which is 0.010. So just plug that into your calculator. We get the natural log of the C4H8 concentration at 0.010 seconds. Now, this is just a subscript telling us what time we want. That is not going to come into play into the equation at all. That's just telling us this is the concentration after 0.010 seconds. And that's going to equal, you're going to subtract that. The natural log of 2 is 0.693, and that's going to equal negative 0.87 because we did 87 times 0.10. Move the 0.693 to the other side by adding, of course, right? And the natural log of the C4H8 concentration of 0.010 seconds is going to equal negative 0.177. And then, like I said at the beginning of the video, all you have to do is take E raised to the power of your answer there. So this is going to be E to the negative 0.177, and that is going to equal 0.83 molar. Now, E button on your calculator. It's very easy to get. It's you hit second LN. So the same button that you took for the natural log of 2, you hit second and then LN, right? And then you just type in your number, negative 0.177. And equal. And that's what we get. Hardest part about this problem is knowing what the inverse of the natural log is. But the inverse to the natural log is you take E to whatever power that is. So that's determining the concentration. Let's do a little bit more algebraically involved problem. And do page 15-13, example 2. We have SO2, Cl2, yields SO2 plus Cl2. And it says the decomposition of SO2, Cl2 is a first order reaction, given that chemical equation. The rate constant for the reaction is 2.8 times 10 to the negative 3 inverse minutes. So the rate constant, that's K, is 2.8 times 10 to the negative 3 inverse minutes. At 600 Kelvin, the temperature is not going to come into play because the little t is the time, but the rate constant is specific at a specific temperature. It changes with temperature. So anyway, that's that. If the initial concentration of SO2, Cl2, is 1.24 times 10 to the negative third moles per liter. And of course, it says the initial concentration, so that's concentration, the brackets, and 0, standing for the initial, or you can put I, it doesn't matter. If the initial concentration of SO2 Cl2 is 1.24 times 10 to the negative third moles per liter, how long will it take? So we're finding T for the concentration to drop. So concentration of SO2 Cl2 at time T. How long will it take for the concentration to drop? 0.31 times 10 to the negative 3 moles per liter. So we're going to use the integrated rate law. Natural log of the concentration at time t minus the natural log of the concentration initial is equal to the negative rate constant times the time. So very easy. Natural log of 0.31 times 10 to the negative third at time t minus the natural log of 1.24 times 10 to the negative third equals negative 2.8 times 10 to the negative third times time t. You can plug in your numbers. Natural log of 0.31 times 10 to the negative third is negative 8.0789 minus the natural log of 1.24 times 10 to the negative third is a negative 6.6926 equals negative 2.8 times 10 to the negative third times the time. And you can combine like terms because these are both numbers. So negative 8.0789 minus a negative 6.6926 is going to be negative 1.3863. And that's going to equal the negative 2.8 times 10 to the negative third times the time. And then very simply, all you have to do is divide the time by negative 2.8 times 10 to the negative third. And then time is going to equal 495. And K was inverse minutes. So T is going to be minutes. So really don't be afraid when it says integrated rate laws. I am not going to make you take integrals. We'll say that for Mr. Vavilov, but I will give you the integrated rate law and you would just have to plug and chug. Like I said previously, The hardest part about these integrated rate law problems is knowing that the inverse of the natural log is taking e to a certain exponent, which is your answer. That's basically all that I need to cover so far. Thank you very much for learning with me today. I enjoyed learning with you.